Previous video we saw that a series is a sum of terms of an AP or a GP or any sequence. Okay, so we are going to look at in particular AP. Okay, sum of terms in an AP. For this AP, we are going to try to set up intuitively the sum formula for the sum, okay, of terms of this AP. First thing you should know or you should remember is that for the sum of terms in an AP, we denote it as Sn, which is equal to the first term. Okay, we have to look at the first term T1 plus the second term T2 plus the third term T3. These are terms, plus continuously up to the nth term, which we denote by Tn. Okay, this produces the sum of terms in an AP. Okay, now what do we do? What is the meaning of T1? T1 is nothing but A. Okay, T2 again is nothing but A plus D. D is the common difference. We should know that, right? T3 is A plus 2D, and so on. And then Tn is going to be equal to the last term, which we denote as A plus n minus 1d. Okay, A minus 1d. But I'm not going to be writing this as n A plus n minus 1d. I'm going to be using L for it to mean the last term. If you remember, we always use Tn as the last term. Okay, so the last term is also equal to L. Okay, Tn equal to L. Okay, and then it is also equal to A plus n minus 1d. We'll use it at the appropriate time. Okay, now this is it. If I want to find, okay, make sure you are taking your note. Please make sure you are taking your note because test is coming on. Okay, Sn is going to be the first term, which is A, plus the second term, which is A plus D, plus the third term, which is A plus 2D, plus continuously L plus L. See that? That is it. So now I am going to refer back to our video. The previous video, we were able to reverse the series to be able to get the sum of two terms, then we divided by 2. That's what we're going to apply here. Okay, so reversing this, what do we obtain when we reverse this? We say therefore Sn is again equal to, is the same, starting with the last term L plus what's going to be the next term after, or the term just before L is going to be nothing but L minus D. Think about it carefully. Okay, then plus L minus 2D. Think about this. Then plus continuously the first term A. See that? This is what we have. This is very straightforward. Now the thing now is, how do we get the sum? Okay, what we did in the previous video, we added 1 and 2. Let me call this one 1 and let me call this one 2. Okay, so add 1 and 2. You may be asked to prove this formula. Okay, there's a formula we're going to arrive at. So now when we do so, we're going to have therefore Sn plus Sn is going to produce 2Sn. Simple, right? Okay, A plus L is just A plus L. First term and last term added together to produce L. See? Then plus second term plus second to the last term. This is second to the last term. It's going to, if you notice, this is D and this is minus D. When you add them together, they cancel out. And so you're going to have A plus L left. A plus L. You see, it is giving me something unique, right? A plus L here and A plus L here. Let me change my pen. Change it. Okay, so now this is what we have. Okay, then the next one, if you notice again, 2D minus 2D will cancel out. So A plus L again, A plus L plus continuously plus last term first term A plus L. See that? That's what we're going to have. Okay, so now uniquely they are the same. See, they are uniquely the same. So what to do now? This plus this plus is something similar. We are adding throughout. How many terms are here? That is the first question you ask yourself. How many terms do we have in this? A plus L, another A plus L up to n times. So that means that we're going to have this, one of them times n, to produce 2Sn is equal to n A plus L. See? Simple, right? So now, therefore, my Sn is going to give me what? N over 2 A plus L. This is the formula with which we calculate the sum of terms in an AP. Okay, with this formula I can calculate any sum of an AP. Okay, but remember L is always equal to the nth term, which is also equal to what? A plus n minus 1 d. I am going to put this in this. Let me call this one equation 3. Okay, so that means that I'm going to have Sn written in a different form, n over 2, like this. Okay, like this. So we're going to have A here plus L is just A plus n minus 1 d. See that? Like this. And so this simplifies further as like this. This is 2a, because a plus a is 2a, then plus n minus 1 d. Like this. Right? That is it. Now, I have my formula. This is the second formula with which we calculate. There are two formulas or two formulas with which we calculate the sum of terms in an AP. Okay? Now, with this formula, let's take some simple example. Okay? If you notice, n means the number of terms. Okay? A is the first term. L is the L term, last term. And then so on and so forth. Okay? Let's see. This is a question. Find examples. Examples. Make sure you update your note. Find the following sums. A. The first one, A. I am going to find, we have 60, we have 91 plus 91 plus 122 plus 153 plus 184. Okay, how many terms are here? 1, 2, 3, 4, 5. Simple. I can just pick up my calculator and add up all the terms, and so I'm going to get the sum, right? But that's going to be a little bit it's going to be a little bit unorthodox. Okay, so we're going to be having the formula first, calculate it. So that's going to show that we know what we are doing. Let's apply the formula. Okay, so the first term here is going to be equal to 60. The common difference clearly is going to be equal to this minus this, which is 31. And then the last term, L, is given as 184. So number of terms is equal to 5. So that means that I'm finding the sum of the first 5 terms. First 5 terms, like this. Sum of the first 5 terms. So this is going to produce 5. Let me use this one. This is suitable because I have the last term given to me and the number of terms. Okay, so I'm going to have 5 over 2 bracket. The first term is 60 plus the last term is what? 184. So you see, somebody that will pick up a calculator to add up will not be able to do this quicker than you. Okay, if you know what you're doing. Okay, so first 5 terms will be added up to give 5 over 2 times 184 plus 60 is going to be what? 224. 224. Okay, 244. Sorry, 244. Okay, 244. 244, right? So 2 here, 1. 2 into 44 is going to be 122. 122. So 122 S5 times 122 is going to be equal to 5 times 2 is 10, carry 1. 5 times 2, 10, 11, carry 1. 5 times 1, this is 610. So that's it. That is it. Sum of the first n terms is that, right? Now let's look at the second one quickly. The second one, B. In B, we have the first term is 3. So I write A is equal to 3. Right? Then the common difference, D, is equal to what? Common difference is equal to 3. Also, right? Common difference, a term minus the preceding term, right? Then the number of terms, is it given? Is the number of terms given? No, but we are told that as far as the 20th term, that means n has to be 20. As far as the 20th term, n has to be 20, right? As far as the 20th term, n has to be 20. So that suggests that we cannot use this first formula. We can only use the second formula, right? So that means we're going to have, therefore, Sn is equal to, quote the formula, n over 2, like this, 2a plus n minus 1d, common difference. Okay, I have quoted the formula. Now I can substitute this. I have everything I need, right? I have everything I need. I have the number of terms, which is 20. I have the common difference, which is 3. And then what again? I have everything I need. So that means that S20 now, first 20 terms, as far as the 20 terms, 20th term, okay, over 2, like this, 2 times, what's my first term? 3 plus, what is n? N is 20 minus 1 times, the common difference is 3, like this, like this. So that means that S20 is equal to 10. You can see, I can just use this kind of bracket because this is going to be 6 plus 19 times 3 is 57. Okay, just 60 minus 3 is 57, like this. So I'm going to have 57 plus this is 63 times 10 is 630. So my sum is 630. Okay, that's it. Okay, then the third one. The third one, quickly. Here we have the third one. I'm not going to do the third one. It's just very easy, just like the first time, right? Okay, not really. So the third one, the first term is equal to what? 3. The second term, the common difference is equal to 5. And then the last term is equal to 48. But notice something. There are not 5 terms here. No, we don't have 5 terms here. What we have here is many terms. We don't know the number of terms. So we have to find n. We have to find n. So now, n is equals to question mark. How do we find n? Like in our previous video, we can say n is question mark. We can now link up n with tn. Tn is equals to a plus n minus 1d. Okay, so we can use this to find n. Therefore, because n is essential in the formula, so we're going to have the last term is 48. So I have 48. Link it up with the last term so you can get it. 48 plus a is what? The first term is what? 3 plus n minus 1. The common difference is 5. So it means that I have 48 plus is equal to 48 is equal to 3 plus 5n minus 5. So 5n now is going to be equal to 48 minus 3 plus 5. So 5n is equal to 48 minus 3 plus 5 is 50. So n is equal to 10. So that means that sum. What sum am I finding? The question says find the sum of this AP, right? So sum of first 10 terms. So S10 now. Okay, so let me quote the formula. Actually, this is the formula, the right one to use, because I can actually use any. I can use any. Let me use this one. It's simpler, right? You can use any. A plus L. You can use L, any. You have the last term, right? You can use it. So that means that S10 now is going to be equal to 10 over 2. Then the first term is what? 3. Plus the last term is 48. I think that's all, right? So now we have, this is 5 bracket 3 plus this is 51, right? So S10 now is equal to 51 times 5. 5 times 1 is 5. 5 times 5 is